Welcome to the deep dive. Today, we're tackling the space and time white paper.
Yeah, it's a really interesting one.
Our mission really is pretty straightforward.
Yep.
Cut through the technical jargon and understand how this tech aims to unlock Web3 data.
Right, fixing that fundamental problem smart contracts have with, well, limited data access.
Exactly. Think of this as your express route to getting the core problem, their solution, and why it could be such a big deal for Web3. We're looking for those aha moments.
Think so.
Okay, so let's unpack this.
Well, the main challenge, the thing we're up against, is that smart contracts, even though they power so much of DeFi, they operate with surprisingly little visibility. They're great for managing assets, on EVM chains.
Yeah.
But they mostly see just what's happening right now.
Like current balances, recent transactions.
Exactly. Balances, transactions, some basic blockchain info, and their own internal state. But trying to directly query historical data that's already on the chain, that's a major hurdle.
Right. And that's not just some technical detail, is it? It has real consequences.
For sure.
Think about Aave, a big lending platform. Right now, they can't easily tell a new borrower from someone with, a solid repayment history on chain.
Which means they can't really offer custom loan terms based on verifiable history. No real on-chain credit scores.
Exactly. No credit scores means pretty basic lending. And here's where it gets really interesting. Think about TradFi. Options markets are massive, right? Huge volume.
Way bigger than the underlying spot markets often.
But on-chain options, pretty rare, relatively speaking. Why? Because building trustless options needs complex external data processing, stuff standard contracts just can't do.
Whereas you look at perpetual futures on-chain, they're thriving.
Right, because they only need simpler data, like token price feeds, which are easier to get.
So the key takeaway there is data availability is a direct bottleneck. It's holding back DeFi innovation.
Okay, so if that's the problem, what about current solutions? People must be trying things.
Well, yeah, there are workarounds, but they have their own issues. Zero-knowledge proofs, ZK proofs, they're powerful. They let you verify data without revealing it.
Sounds ideal, right? Like giving smart contracts extra processing power.
It does. Offloading computation and proving the result on chain, it's like a specialized coprocessor, kind of. But ZK tech is still pretty new, still evolving. There are definitely challenges, development hurdles.
Right. Still maturing. So this data limitation, it really clashes with the whole Web3 vision, doesn't it?
Absolutely. Web3 is supposed to be about moving away from, big tech controlling all our data.
It's about individual control, your data, your privacy, managed through your wallet, transparent governance.
And the white paper suggests this idea of a community-run database model. A way to reclaim that data control, where rules for access and use are collectively decided.
So how do we bridge that gap between the Web3 ideal and the current blockchain data limits?
That's the core question. Existing blockchains, they're mostly like single append-only ledgers. Amazing tech, but they lack the kind of query power needed for complex dApps. Sometimes leads to state bloat too.
Right, things get slow.
Yeah. And what's clear is that modern dApps need more flexibility. They need to talk to data across different chains, but still keep everything trustless.
Okay, so problem defined. Smart contracts are data-starved, hindering innovation and the Web3 dream. Let's get into the solution. The SXT chain and proof of SQL.
Yes. This looks like their answer. Proof of SQL is the core innovation here. It's aimed at unlocking that co-processing for smart contracts, enabling ZK-proven queries on-chain.
So the fundamental idea.
It's actually quite elegant. Allow smart contracts to basically ask ZK-proven questions. Questions about on-chain activity, off-chain activity, cross-chain, using SQL.
SQL. That's huge. Millions of developers already know SQL.
Exactly. It lowers the barrier to entry significantly.
And that's where the aha moments really kick in. The white paper gives some great examples, like risk-based lending, a protocol asking, show me this wallet's loan repayment history for a discount.
Yeah, or advanced DeFi strategies. Find all liquidity pools over $1 TVL active for more than a month.
These examples, they all point to one thing. Proof of SQL turns smart contracts from simple calculators into, data analysts. They can understand history, context.
It goes way beyond that. Think cross-chain insights. Sum up our total collateral across Ethereum, Polygon, and Avalanche right now.
Or on-chain loyalty programs. Check this trader's history on RDX for a fee discount.
Totally. Or dynamic LP management, maybe using Uniswap v4 hooks. Alert me if token A price deviates more than 10% from token B, triggering a rebalance.
Aggregating market data, too.
Yeah.
What's the average stablecoin lending rate across DII, Compound, etc.?
Yep. even targeted airdrops. Find wallets holding X amount of token Y that have used the contract. Much more precise.
Cross-chain tracking, like monitoring big token movements across bridges, Web3 gaming rewarding achievements based on playtime or NFT ownership.
Uh-huh. They even mentioned pulling in TradFi data, like implied volatility from CeFi options markets. The scope is just really broad.
It really paints a picture of how verifiable data access changes the game for Web3. So what were the main design goals behind building this?
Okay, the design goals are key. First, end-to-end trustless. They're leaning heavily on ZK proofs to avoid relying on just a few permission nodes. That should help scalability and reduce trust assumptions.
Makes sense. What else?
Second, verifiable on-chain. This is crucial. The ZK proofs generated off-chain need to be verifiable within the limits of the EVM itself. So a smart contract on Ethereum, say, can directly check the proof.
That on-chain check sounds vital for real decentralization. Any other core principles?
Yeah, a familiar developer experience. Using SQL, like we said, that's huge for bringing in Web2 devs. Also support for arbitrary computations. Using SQL, not just simple lookups, but complex stuff like joins, aggregations.
Those powerful queries.
Right. And low latency at scale, getting verified results fast, even over big data sets. And finally, comprehensive chain data coverage. Storing full copies of major chains to enable those rich cross-chain historical queries.
Okay, so that's the vision. How does the network actually work? What are the pieces?
It's a layered system with different node types. First, indexer nodes. These are basically lightweight servers, pulling data from blockchains, processing it, making it SQL ready.
Like prepping the ingredients.
Exactly. They transform the raw data and submit it to the SXT chain.
Got it. Indexers prep the data, then what?
Then you have prover nodes. These are the heavy lifters. They run the SQL queries and generate the ZK proofs that vouch for the result's accuracy.
They do the math and create the proof.
Precisely. Then there are the SXT chain validators.
Yeah.
Their job is to secure the data commitments like fingerprints of the data and verify the ZK proofs coming from the provers.
Okay, validators check the work.
And finally, you've got the target chain and off-chain components. That's just the blockchains being indexed and any external data sources being pulled in.
Sounds like a well-oiled machine, ideally. The white paper also talks about a decentralized database design. How does that fit in?
That's a core piece. It lets smart contracts offload computation and data stored efficiently. This boosts scalability, can make contracts faster, and potentially lowers gas costs on the main chain.
Offloading work.
Yeah. And it stays permissionless. Interestingly, they also mentioned potentially using proof of SQL as a settlement layer for ZK rollups. That's another scaling angle.
That is interesting. What are the main upsides of this decentralized database approach?
Well, a few big ones. Decentralization with self-custody data is stored and processed across community nodes. Access control uses something called biscuits.
Biscuits, like digital permission slips.
Kind of, yeah.
Yeah.
They allow really specific fine-grained access control. Users can even manage access to their data in public tables. Then there's cross-chain interoperability, a contract on one chain querying historical data from another using custom SQL.
Powerful.
And finally, joining on-chain and off-chain data, combining different sources, all with ZK-proven computation.
Okay, so how does the actual on-chain verification work? How does SXT talk back to, say, Ethereum?
There's a special smart contract, an SXT chain query relayer, deployed on the target EVM chain. A client contract wanting data interacts with this relayer.
So the contract calls the relayer.
Right. Sends a small payment, a query ID. This triggers an event that SXT nodes are listening for. A prover node gets picked, runs the query, generates the proof.
And then
Then that prover acts like a ZK oracle. It sends the query result and the ZK proof back to the relayer contract on the EVM chain. The client contract can then verify the proof and use the result.
got it. That relayer is the bridge. Okay, let's dip into the tech weeds a bit. Proof of SQL protocol architecture. Can you give us the high-level stages, like a pipeline?
Sure. Think of it in roughly 4 main steps. First, the parser. It takes the SQL query text and translates it into a machine-friendly structure, an abstract syntax tree, or AST, like understanding the question.
Okay, parser translates SQL to AST.
Second, the query executor and interactive protocol builder. This is where the query actually runs, but also where the framework for the ZK proof gets built simultaneously.
Running the query and setting up the proof.
Exactly. Third, the relation prover. This uses a core crypto technique, the multilinear sum-check protocol, to generate the bulk of the proof. Think of it as efficiently verifying a complex calculation.
Sum check for the main proof.
And fourth, the commitment evaluator. This final stage checks the integrity of the underlying data used in the query by verifying cryptographic commitments made to that data. Figure 5 in the paper gives a good visual.
So that AST the parser creates, what does it look like conceptually?
It's basically a tree structure representing the query. Figure 6 shows an example. So something like select hash from blocks, where block 1000, the AST would show the select, the from, and a filter node connected to the block 1000 condition. It breaks the query down logically.
Okay, that makes sense. Then the query executor and protocol builder stage. What's really going on there?
Right, so it executes the query and builds the proof protocol. They mention it's initially interactive, but uses fiat shamir to make it non-interactive, which is more efficient.
Yeah.
No back and forth needed.
Fiat shamir. Okay.
For each node in that AST, the prover does 4 things. Runs that part of the query, generates a witness, intermediate data for the proof, creates cryptographic commitments to that witness, and builds the mathematical constraints linking everything. Some parts need a 2-round process using random challenges, simulated via fiat shamir.
Commitments keep coming up. Why are they so vital?
Commitments are crucial. They're like cryptographic seals on the data. Once committed, the prover can't secretly change the data used for the query. It locks it in. The paper nodes creating them can be intensive, sometimes needing GPUs.
Okay. And that leads to the last 2 stages, relation prover and commitment evaluator.
Yep. The relation prover uses that sum check protocol, translating SQL ops and constraints into polynomial equations that are fast to verify. Then the commitment evaluator checks that the commitments the prover made match the claimed query result. It involves opening parts of the commitments.
And they use specific commitment schemes, right? Dory and HyperKZG.
Right, and they're working on a new one, too. These are chosen because they're efficient, especially for verification. And crucially, they have properties like being updatable and sometimes homomorphic.
Updatable. Why is that so important for a database that's always changing?
Absolutely critical. Data keeps getting added. Updatable commitments mean the verifier can add new data commitments efficiently without reprocessing everything old. Homomorphism lets you do certain computations directly on the commitments themselves, like making summaries.
And Dory versus HyperKZG trade-off.
Exactly. Dory is transparent, no trusted setup needed, which is a plus. It's also good for partition data. HyperKZG does need a trusted setup, but its proofs are very efficient to verify on-chain, especially on Ethereum. Having both gives flexibility.
Okay, wow, that's quite the technical dive. Let's zoom back out. The paper talks about use cases for this next-gen Web3. What stood out?
Oh, loads of potential applications. Flexible ZK rollup infrastructure, maybe using proof of SQL for settlement. Truly decentralized backends for dApps, getting rid of those centralized servers many still use.
That data-driven lending example with dynamic rates based on verified credit scores, that seems huge.
It really is. Imagine lending contracts accessing ZK-proven history across platforms to offer better rates, good for lenders, good for responsible borrowers, and creating genuinely cross-chain financial instruments becomes feasible.
What about social apps? They mentioned tackling challenges there, too.
Yeah, decentralized social faces big hurdles. Massive data, fair creator rewards, bootstrapping content, private interactions. Space and Time's tamper-proof tables could handle the data scale. ZK-proven metrics could enable fair, transparent creator payouts. Shared datasets could help new communities. ZK-proofs might even allow private messages with verified authenticity.
Verifiable institutional finance. That sounds transformative, too.
For institutions, yeah. Trust, compliance are everything. A verifiable SQL database for tamper-proof P&L, order books that simplifies audits, GDPR compliance massively. Managing data sovereignty across regions while doing global analytics, big win. Tamper-proof order books could change how they operate.
And RWAs, real-world assets. How does this help tokenization?
RWAs often mix static info with dynamic data. Space and Time lets contracts securely query the latest dynamic details, think property valuations, loan statuses, ensuring accuracy. Plus, verifiable backends for compliance, storing wallet histories, risk scores, whitelist, blacklist securely, crucial for compliant RWA platforms.
Right. And we also saw things like better transaction security, wallet whitelisting, trustless LP rebalancing, and AMM.
Exactly. Security platforms using verifiable history for risk assessment. More robust whitelisting with ZK proofs. AM's rebalancing based on real-time data, trustlessly, potentially reducing impermanent loss without needing oracles or keepers in the traditional sense.
Okay, these use cases really highlight the impact. Let's shift to the economics. How does the SXT chain sustain itself? What are the incentives?
The model aims to reward everyone involved. Validators securing the network, table owners providing good data, provers processing queries efficiently. The SXT token is key.
How so?
Validators have to stake SXT as collateral, skin in the game. It secures the network data commitments, insertions, ZK queries. It's also at risk. They can get slashed, lose some stake for bad behavior, downtime, unverifiable queries, etc.
So staking SXT is a commitment to network health. How are stakers rewarded?
They earn rewards from network fees, query fees, data insertion fees. These flow into a security budget vault. Stakers can be node operators or just delegate their SXT. Early on, there's also some planned SXT token emission to supplement fees and bootstrap the network.
Okay, that covers validators. What about the people providing the data, the table owners?
They get rewarded too via a table owner rewards vault. They earn fees when data is inserted into their tables, and crucially, they get a share of the query fees when users access their data.
So there's a direct incentive to contribute valuable, popular data.
Exactly. And they can even delegate some of their fee earnings to specific provers to encourage fast, reliable queries on their tables. Creates a nice market dynamic.
Seems well thought out, aligning incentives. The paper also contrasts what smart contracts can access natively versus what space and time enables. Quick recap.
Sure, natively, contracts see basic stuff. Block details, gas, current transaction info, balances, their own storage, other contract interactions, ether ops. What they can't see directly is huge. Past events, deep historical data, prices, real-world info, off-chain data, states on other chains. They need oracles for that now.
And space and time aims to bridge that gap with verifiable SQL queries.
Precisely, over a much wider range of data sources.
And how does proof of SQL guarantee the integrity of all this?
It relies on provers accessing the database, while validators act as watchdogs, logging cryptographic fingerprints, commitments of the data. ZK-verified queries go through validators. Plus, they offer a client-side library so users can create verified commitments themselves, controlling the trust root.
The paper also briefly compared their append-only database to a blockchain.
Yeah, it noted an append-only DB can mimic immutability, ordering, consistency to some extent. But it lacks the inherent zero-trust security, concurrency handling, crypto guarantees, and finality of a true blockchain. Proof of SQL is designed to add those layers of trust and security back in.
Totally. And the market opportunity here seems massive based on the Web3 stats they shared.
Totally. Trillions settled daily, millions of contracts, tens of thousands of dapps and devs. The scale is there. Data warehousing is already huge in Web 2. Space and Time positions itself as a unified platform for both transaction-like OLTP and analytical OLA queries in Web 3, which is needed. Their existing traction with enterprises backs this up.
And this idea of verifiable compute seems fundamental.
It really is. It shifts the paradigm. You don't need to trust who did the computation or where the data came from. Just verify the proof. Huge implications for AI training audits, compliance, data lineage. They claim significant integration already, which is telling.
So it's about trust in the computation, not just the transaction.
Exactly. There's massive demand for trustless data verification and accurate computation. Enterprises increasingly need data assurance.
Okay, let's wrap this up. Core takeaways from this deep dive into space and time.
I'd say the key insight is that it offers a really novel solution to Web3's data bottleneck. By enabling ZK-proven SQL queries over all sorts of data, on-chain and off, it unlocks a huge range of new apps and boosts trust and transparency.
Yeah, and for me, the real aha moment is combining SQL's power and familiarity with ZK-proof's trustless verification. That feels like a really critical piece for building a more capable, data-driven Web3.
So the final thought for you, the listener, of this: what happens when you have truly verifiable data and computation underpinning decentralized apps? What completely new possibilities does that unlock for the internet, for finance, for everything? What limitations that we just accept today could actually disappear?